Hi, my name is Alden Kruse. Here I am in my backyard in Black Forest, Colorado, and I'm excited to tell you about my project, Mysteries in the Mud, tracking the human impact of environmental change using a heat pressure extracted pond sediment core. So before I jump into my project, I wanted to give you a little bit of background. First off, on sediment coring. So sediment coring, basically what is it? So the sediment itself, it accumulates year by year, layer by layer, from organic matter and just by like slow accumulation of organic matter and water runoff. And then this creates layer by layer, year by year, and all you have to do is core it. And then you're able to just basically have like a time capsule of what the environment was like during that time. Now, sediment coring is usually used on either Antarctica or very deep oceans or very deep ponds, but not usually in a local pond in your backyard. But that's exactly what I wanted to do. So, as I said, I live in Black Forest. And the reason I wanted to study Black Forest is first off, it's in my backyard. But second, it's actually super cool because it has a ton of historical data. Like in 1880s or 1860s, it was massively logged, and that was its main source of income. But then in the 1880s, it was used more for cattle and ranching. But now in the 2020s and before in the 1990s, it's now being used for like residential housing and stuff like that. So a lot of historical data, but doesn't have the ecological impacts of these changes. And so basically that's what I wanted to do with this project. So my research question was, could I create a tool to collect sediment cores and create a technique to evaluate the cores to see whether environmental changes is captured in the pond sediment record? My hypothesis was that one, I'd be able to collect a pond sediment core from the pond bottom without disturbing the layers. Two, the core shows seasonal sedimentary layers. And then finally, when analyzing the core, I'd see a significant shift in composition as houses started being built near the pond. So the purpose of this project, and basically what I was doing was, first off, I needed to create a tool and a method to collect these cores from a small pond in Black Forest. And then second off, I needed to create a way that I'd be able to analyze these cores to see the environmental change on them. So now to get into my methods. First off, on sediment coring. So I actually had to build my own core because cores can range from $150 to $500. And so I didn't want to pay that money, so I decided to create my own. My design criteria for this was that it'd be easy to use, modular system, inexpensive, reliable, and it had the capability of travel. So the engineering design I built off this was that it'd just be one piece, easy to use. It'd have a detachable core sample, and that was going to use PVC pipe, which makes it inexpensive. And then I applied my own technique of using a heat pressure based system, which I'll get into a little bit further. But then finally, I was going to make it one long piece, making it easy to transport. The method I used to obtain the core was that I'd first off identify the point on the pond where it'd probably be the deepest in water. And then I would drill through the ice, which was about 12 inches thick, which took about 45 minutes each time I did it. Next off, I would then insert my corer into the sediment itself, and then I would apply my full body weight onto the core so that it would be able to get all of the sediment. Now, this is where my heat pressure based system came in handy. What I would do is I'd pour in hot water into the top of the sediment core itself, or not the sediment core, the corer. And then what would happen is, because when hot water is hot, it expands, and when it cools off, it compresses. So all I needed to do was pour in boiling hot water, and then I'd apply a cap and then wrap it around with electrical tape. And then I would just wait, and that created this suction so I wouldn't lose my sediment core. After that, I would pull gently to remove it out of the sediment and get it out of the ice. And then after this, all I needed to do was just cap the bottom and transport it back to my home, which then I would just cut off the PVC pipe and I'd have my core. Now, the variables I was looking for in this project was, one, I was going to be looking for diatoms. The reason I chose diatoms is because they account for taking over 40% of our Earth's CO2. So I wanted to see if they were increasing over time or decreasing. Next, I wanted to measure and see the sediment pH. The reason that this is important is when CO2 increases, it makes the pH of water decrease, making it more acidic. So this would be a good indicator of seeing how much CO2 is in the atmosphere at that time. Then I wanted to measure sediment conductivity. Sediment conductivity has a direct link to human disturbance, which basically what that means is when people use fertilizers or stuff like that, that raises the conductivity of this pond sediment. Finally, I wanted to x-ray my core. The reason for this is that when you have lower densities, it will show up darker on the x-ray, which will indicate more plant life, because when they die, they sink to the bottom, which then makes the sediment less dense than just pure dirt or sediment or water runoff. So how is I going to get these variables? First off, with diatoms, the method I used to analyze for diatoms was that I would grab every 7 centimeters on the core, I would chop it off and take 1 centimeter of that. Then I would take 1 milliliter of it, and then all I had to do is dilute it with 10 milliliters of distilled water, which then I would put in a thing called a hemocytometer. I would just put 1 drop on the very center of this hemocytometer, and I would look at it underneath the microscope at 500 times magnification, which I had to count each one of these squares you see on the hemocytometer, which took about an hour each one, which I did 10 of them, so very time consuming. Next off, one that was a little easier was pH. All that I needed to do was just take 1 milliliter of the sediment and then dilute it with 10 milliliters of distilled water. And then I would just measure the pH with a pH meter. I did almost the same thing with sediment conductivity, except use a sediment conductivity meter instead. And then finally, for the x-raying, what I did is I sent it off to my local veterinarian, which they were very, very kind, and they were able to x-ray my core for me. And you can actually see it right below it. You can compare it to the real core itself. And then all I needed to do was just x-ray it, and then I put in pins to make sure I knew where I was on the core. So the results. After I'd done all this testing, after I'd spent numerous hours on the pond analyzing for diatoms, doing all this testing, these were the results. So first off, with conductivity. Conductivity was super cool because you're able to see that in the first sample, 63 centimeters down, which is the oldest, it had high conductivity. And the thing that makes this neat is that shows that we actually reached the pond bottom and we got all of the sediment. Because when you reach the bottom of the pond, then bottom of the sediment, that's going to raise the conductivity because clay is more conductive than just the regular sediment. But then you're able to see the rest of the sediment conductivity stays relatively low until we get to the 7 centimeter and 1 centimeter mark. We see an increase that was about 3 times higher than all the previous samples. Next, with the diatoms, we were able to see it stayed very low the entire time until we got to the 14 centimeter mark, which is we see a huge increase of 795%. So this is kind of crazy, and I was wondering why it's happening. But then I saw the same thing happen with the pH. Hey there, sorry, my computer just disconnected because it was super cold outside, so it shut down. We're back. Back to the pH, we were able to see that there was a decrease from the 14 centimeter mark to the 1 centimeter mark, which we saw that same decrease in the diatoms and conductivity, or there was an increase of conductivity in diatoms. We were able to see it change at the same time on the core. And then finally, with the x-ray, we were able to see the same change, except with its density. And we were able to see that there was much darker, which, as I said in the beginning, that meant that there was more plant life during that time, or organic matter. So after I found this, all 4 of my variables showed the same thing. There's either a huge increase or decrease in the final 14 centimeters. So I wanted to find out what time this was when this was happening. And so I needed to figure out a way to date my core. And so what I did is I knew the pond itself was built in 1880. And so that made it 140 years old. The core itself was 70 centimeters. So that meant that every 5 millimeters, there was a change. Every 5 millimeters, that meant there was 1 year. And so you can see this graph on the right over here. What this is saying is that the very first layer is going to be much bigger than the last layer because it only has the water resting on top of it. But the last layer has all of the sediment and all the water on top. So it's going to be more compressed. So we were able to find out that when all these changes in our variables happened was in the year 1990, which you can see this graph right here shows that there was a huge increase of the number of houses being built around the pond in 1990. You're able to see this huge spike during that time. So that led us to think that all four of that the pond itself was being affected by these houses coming in. So as you can see, this is all four of the graphs having either that huge increase or decrease during the same time that the number of houses were being built. So as I was saying, the key findings of this was that there was a direct correlation to all four of our variables and the houses being built. So in conclusion, because of this close relationship between the development and changes in the sediment record, we could conclude that the pond sediment can be a record of nearby ecological shifts. So discussion of like why these changes happen or what may have caused it. First off, with diatoms, some research has been done that has indicated that increased CO2 increases the number of diatoms. So that kind of makes sense because the number of houses increased and the number of diatoms also increased. Next off, with conductivity, the reason that, as I said in the beginning, was that when conductivity increases, that means that more human disturbance has happened in this pond. As you can see below, this kind of talks about how when increased conductivity may indicate that there was a discharge of some other source of disturbance. Then next with pH, we are able to see that decrease of pH in those final centimeters. And so, as I said in the very beginning, when pH decreases, the amount of CO2 increases because when CO2 increases, it makes the water more acidic. And so this indicates that during that time period of all the houses being built, the amount of CO2 increased. Then finally with the X-ray, as I was saying, when the density decreases, makes it darker, as we saw in the X-ray, that means that there's more plant life or organic carbon. And so this means that there's probably more plant life during this time as well. So more plants were growing when houses started coming in. So some future research I'd like to do is, first off, take core samples from a place where there isn't as many houses as Black Forest. Then I'd like to do the exact opposite, which is test a place where there are way more houses than Black Forest, like in Denver or like Sloan Lake. Then I'd like to analyze it specifically to the density layers from the X-ray because I was expecting to see layers when I got my core, but I didn't see any. And so I wanted to analyze this specific to the X-ray itself. Then finally, I'd like to study charcoal layers representative of fires. So what this means is that when fires happen, the charcoal layer happens or falls onto the pond, making a charcoal layer on the pond. So you'll be able to find out when fires happen. Finally, I'd like to analyze the core sample for pollen because this is you're able to tell what trees let off which pollen or how much. So this is the future research I'd like to do. And then finally, with some acknowledgments that I'd like to give out is, first off, to my mentor, Dr. Leonard, and my other mentor, my older brother, Caleb Kruse. I'd like to thank my other older brother, Shepard Kruse, for all of his manual labor. And then my mom, who is my teacher, who inspires me to do this stuff. And then finally, my dad, who tested the ice first. So glad that he was able to do that for me. So in conclusion, I was able to find that there was a direct link to all four of my variables to this pond sediment core. Do you have any questions?